For most of this war, the term thermobaric weapon has meant one thing: mass destruction. It's a term that's almost synonymous with the TOS-1A Solntsepyok, a Russian rocket launcher that fires 24 warheads in a single volley, or the ODAB-1500, a 1,500 kilogram glide bomb that produces a mushroom cloud visible from miles away. Both have been used by Russia in populated areas during the war, actions that form part of broader allegations of war crimes being investigated by the International Criminal Court. That's the doctrine the world learned to associate with Russia so far: bigger is better. The more of an area you can render uninhabitable in one strike, the more effective the weapon. And civilians caught inside that footprint are an acceptable and perhaps even the intentional cost. But Ukraine has gone the other way. For them, less is more. Ukraine showed up at a defense expo in Paris in June 2026 with a thermobaric weapon that weighs only half a kilogram and fits in a cargo pocket. With that weapon, it's quietly rewriting what this entire category of weapon is supposed to be for. Instead of mass casualties, the weapons are being recalibrated toward precision, where the target is a single room, trench or vehicle. We're going to explain how thermobaric weapons actually work, why Russia and Ukraine ended up on opposite ends of the same technology, and what Ukraine's brand new grenade, together with the drone doctrine now being built around it, tells us about where the close quarters fight in this war is heading next. Let's start with the mechanism behind thermobaric weapons. A conventional explosive is a single self-contained event. A solid or liquid compound detonates, releasing all of its energy in one fast chemical reaction, and the damage comes from the blast wave and the fragments that go with it. However, a thermobaric weapon is a two-stage process. Inside the munition is a fuel container paired with two separate explosive charges. The first charge detonates and disperses the fuel as a cloud of fine aerosol, spraying it in the surrounding air. A fraction of a second later, the second charge ignites that cloud, and because the fuel is now mixed through the atmosphere rather than sitting in a container, it burns using the oxygen already present in the air around it. The result is not a sharp, instantaneous bang, but a sustained pressure wave and a fireball that lingers, burning longer and pushing that overpressure further outward than a conventional charge of the same size ever could. That detail, the bit about needing the surrounding air to burn, is the single most important thing to understand about these weapons, because it explains both why they're terrifying and why they're limited. In open terrain, with nothing to reflect the blast, a thermobaric weapon is a genuinely less impressive weapon. The pressure wave there simply expands outward and dissipates. But put that same weapon inside an enclosed or even a partially enclosed space, and everything changes. The overpressure has nowhere to go. Instead, it reflects off every wall, compounds on itself, and arrives at a target from multiple directions in the same instant. US Army reference material describes the effect as a long-duration pressure and vacuum surge that can rupture soft tissue the way it tears aircraft skin or radar surfaces, and walls don't shield the people inside. They amplify the tearing effect by bouncing the wave back and forth. On top of that, the fireball consumes the oxygen in that enclosed space as it burns, which means anyone who survives the initial blast is now fighting a secondary suffocation effect. So the weapon has been used in cities and against buildings precisely because doing it against true military targets like military infrastructure or single tanks is less effective. In the open, a thermobaric warhead would have to be unwieldily large to be of any use. Russia's approach has always been to scale that room clearance principle up to the size of a neighborhood. The clearest example is the aforementioned TOS-1A Solntsepyok, which means scorching sunlight. It's a 24-barrel, 220mm rocket launcher bolted onto the chassis of a T-72 tank, first developed by the Soviet chemical troops in the 1980s and used in the Panjshir Valley during the war in Afghanistan. The weapon is technically assigned to Russia's nuclear, biological, and chemical protection troops rather than ordinary artillery units, and it's usually attached to maneuver brigades for exactly one job: clearing fixed defensive positions, particularly in urban terrain. Russia used it in Grozny during the Chechen Wars, in Syria, and it crossed into Ukraine within days of the February 2022 invasion, film rolling over the Belarusian border. Each rocket disperses a cloud that ignites at temperatures approaching 3,700 degrees Celsius, and a single salvo can, in the right conditions, functionally erase a residential block's worth of buildings or fortifications. That's the entire Russia doctrine in one platform, one system, one strike, one very large problem for everyone standing inside the engagement area. And then there's the ODAB-1500, which takes the same logic and puts it in the air. This is a 1,500 kilogram thermobaric glide bomb built from Soviet-era bomb bodies fitted with a modern UMPK glide kit that lets Russian aircraft release it dozens of kilometers from the target, well outside the range of most Ukrainian air defenses. Russia first used it against Ukraine in March 2024, striking a village in the Sumy region just a few kilometers from the Russian border, and the footage showed a fireball and a mushroom cloud rising a kilometer into the sky. It has since been used in Kharkiv, Donetsk, and Kupiansk, with the same pattern repeating throughout. Every time Russia dropped it, it was in or near a populated area, with the intention of not only destroying it, but making sure that Ukraine and the world see the extent of the damage Russia can do in one fell swoop. But to go a step further, there's Russia's 2007 test of the so-called father of all bombs, a 7-ton thermobaric weapon. The Kremlin explicitly marketed it as a non-nuclear substitute for a tactical nuke, showing just how they view the potential for thermobaric weapons. As it would turn out, the TOS-1A, for all its terrifying reputation, has proven to be one of the most vulnerable systems in Russia's arsenal in exactly the kind of drone-saturated battlefield Ukraine has built. Its size and thermal signature make it almost impossible to hide. Its bulky launcher doesn't accommodate the coke cages that protect other Russian armor from FPV strikes, and open-source trackers have documented 36 of Russia's estimated pre-war fleet of 48 systems damaged, captured, or destroyed by July 2026. So the single most feared thermobaric platform on the battlefield turns out to be a prime target for the same small, cheap drones that Ukraine has been quietly building an entirely different thermobaric doctrine around. Which brings us to why exactly Ukraine's switch in the other direction is so important. Ukraine inherited a slice of that same Soviet thermobaric legacy after independence, mostly in the form of RPG-7 thermobaric rounds and shoulder-fired flamethrower charges like the Shmel. Ukrainian infantry near Bakhmut have used those inherited Soviet rounds against occupied buildings the same way Russian troops have used them elsewhere. But starting in 2017, Ukroboronprom, the Ukrainian defense industry, unveiled the first RGT-27 hand grenade. It entered service with Ukraine's armed forces in 2020 and was designed from day one to get thrown, or later flown, into a single occupied space. A 600-gram RGT-27 grenade produces a fireball of roughly 13 cubic meters, lasting about 4 seconds and reaching temperatures between 2,500 and 3,000 degrees Celsius, which is more than enough to kill anyone sheltering in an enclosed position while doing nothing essentially to the building itself in the way a rocket salvo would. Ukrainian infantry adopted it for exactly the job it was built for, clearing trenches and fortified buildings where a fragmentation grenade scattershot of metal fragments can miss the corners and dead space that a defender is using for cover. A thermobaric grenade doesn't have that blind spot. The pressure wave fills the entire volume of the room, wraps around obstacles, and turns whatever structure was protecting the defender into the thing that kills them, because the same walls that stop the fragments now reflect and compound the blast. Ukrainian forces then took that same grenade and combined it with one of its greatest inventions in modern warfare, drones. Starting in 2023, one widely shared case from the 59th Motorized Brigade showed a commercial DJI Mavic 3 being used to drop an RGT-27S2 thermobaric grenade directly into the open hatch of an abandoned Russian BPM infantry fighting vehicle, destroying it outright. Neither the grenade nor the drone was purpose-built for that role. Some soldiers simply realized that a 600-gram thermobaric charge, delivered with enough precision through a hatch or a window, could do the same damage as a much larger and far more expensive anti-tank weapon when confined to the close quarters of a tank. And at Eurosatory 2026 in Paris in June, Ukraine revealed the RGT-45 and its smaller sibling, the RGT-45A. On paper, these look like a modest evolution of the same 500-gram and under grenade family. In practice, Ukroboronprom is claiming a jump in lethality that puts them in a different category entirely. The RGT-45 weighs 500 grams and carries 300 grams of thermobaric mixture, and the company states its effective damage volume in an enclosed space exceeds 120 cubic meters. The compact RGT-45A weighs 225 grams with 135 grams of mixture, and its stated effective damage volume exceeds 60 cubic meters. If we compare that to the outgoing RGT-27S2's 13 cubic meters, this isn't a 10 or 20% bump, but closer to a 10-fold increase in the volume of space the weapon can render lethal, achieved without significantly increasing the grenade's weight or size. Ukroboronprom itself frames the improvement as only 20 to 30% more effective overall than the RGT-27S2, and the company has been explicit that the gain comes almost entirely from an upgraded thermobaric chemical mixture rather than a larger form factor. But getting 120 cubic meters of lethal overpressure and heat out of something roughly the size of a large energy drink is a question of chemistry that's actually huge when it comes to weapon development cycles. It means the improvement can likely be folded into future munitions of similar size without another redesign, and that the same mixture being used in a larger munition would drastically increase the potential payload of the weapon. What makes this a bit more interesting than a single new grenade is that Ukraine is actually building an entire family of thermobaric munitions specifically designed around drone delivery. It has essentially acknowledged and continued on the tradition that the aforementioned 59 Brigade Mavic strike started almost accidentally. Alongside the RGT-45 line, Ukroboronprom has also been showing off purpose-built thermobaric bomblets designated TB1 and TB2, explicitly designed to be delivered via drone. The first should be dropped from a multi-rotor drone, while the second is meant to be mounted directly as the warhead on a one-way FPV drone. The TB1 weighs around 2.5 kilograms with a minimum lethal radius of 2.5 meters, and the larger TB2 weighs 4.5 kilograms with a minimum radius of 3.5 meters. And both are built with a universal fuse that should remain functional regardless of weather and moisture conditions. It's the RGT-27 to the RGT-45 story playing out again at a slightly larger scale, except this time the weapon was designed as a drone payload from the prototype. By contrast, the RGT-45 is still, fundamentally, a grenade that happens to be droppable. With the main weapon specs out of the way, let's discuss the tactics behind weapons in confined spaces. But first, make sure you're subscribed to the Military Show so you don't miss any new updates and analytics straight from the front. Now, beyond using thermobaric grenades, there's been a broader trend across modern infantry weapons toward designing specifically for confined spaces rather than treating that as an afterthought. Elsewhere in this war, Western-supplied systems like the Swedish Carl Gustaf recoilless rifle carry a dedicated confined space round, the Heat 655. It swaps the usual gas backblast for a solid countermass, specifically so the weapon can be fired from inside a room without killing its own crew. Ukraine's thermobaric grenade line is chasing the same underlying problem from the opposite direction. Instead of making a big weapon safe to fire indoors, it's making an indoor weapon powerful enough to matter at scale. And Ukrainian units have already built tactics around exactly that kind of delivery. Frontline drone teams, including operators associated with the terror group, have described a two-drone technique for cracking open fortified buildings that Russian troops are using as strong points. The first FPV drone, which carries a conventional high-explosive warhead, punches a hole through the roof or a wall, opening a passage into the structure. The second drone, carrying a thermobaric munition, then flies directly through that opening and detonates inside. It's the trench-clearing logic from years of infantry combat, translated practically one-to-one into the drone age. Instead of a soldier physically approaching a doorway under fire to throw a grenade through it, two drones do the breaching. At no point is a Ukrainian soldier ever exposed to the defender's line of sight. That's the major tactical playoff of a smaller, more energetic thermobaric charge. When you have precise drones that can fly through windows and other small openings, the effective range and viable launch trajectories just get amplified. The same underlying idea is scaling upward too, which broadens what this doctrine can actually accomplish. The Behemoth strike drone, developed by Glefer and Culver Aerospace, and first shown publicly in May 2026, carries a 75-kilogram tandem payload consisting of a 40-kilogram high-explosive fragmentation warhead in the nose, followed by a 35-kilogram thermobaric charge behind it. In June 2026, the drone had already been used against the Chonhar Bridge, connecting the occupied Kherson Oblast to Crimea, disrupting one of the key logistic corridors to the peninsula. But while the drone is enormous compared to the grenades, it shares the same fundamental design philosophy. While the grenade replaces a much larger and less wieldy anti-tank grenade, the Behemoth is meant to replace a cruise missile like the Storm Shadow or Scalp missile, supplied by the British or French. The Storm Shadow has a conventional warhead that weighs approximately 1,300 kilograms, is traditionally air-launched, and most importantly, cost over $1 million to produce. The behemoth's reported costs are between $35,000 and $55,000 for something that's claimed to have a range of over 300 kilometers, so directly competing with the Storm Shadow. Ukraine has even adapted the concept to naval usage. A report in early June suggested that it's adapted the famous Sea Baby by fitting them with Shmel thermobaric grenade launchers and even putting separate FPV drone deployment platforms in the drone boat's side compartment. It essentially made what used to be a single-use drone into a floating multi-weapon platform that can hit entrenched Russian shore positions. The point is, thermobaric weapons showcase the design philosophy that favors precision over mass, applying them from weapons as small as grenades to those meant to replace smaller missiles. Note how this stops at the point of destruction where Russian weapons begin, as they're not meant to replace ballistic or nuclear missiles here, just clear fortified positions and trenches. And that last point is precisely why the thermobaric weapons have become so hotly debated in 2026. You see, throughout the previous 2 years, most of the fighting has been isolated to a relatively stagnant line crossing through the Donbass region. Russia actually built the original defensive line starting in late 2022, a roughly 1,000-kilometer network inside occupied Ukraine. Later known as the Surovikin Line, it consisted of layering minefields, dragon's teeth, and dispersed trench systems, specifically to prevent or reduce the impact of the Ukrainian counter-offensive. And it worked. Ukrainian forces spent most of 2023 grinding through a single sector of it, at enormous cost, and never fully broke through. Then the roles reversed. Facing renewed Russian offensives from 2024 onward, Ukraine built its own version of the same thing, a network called Ukraine's New Donbass Line, stretching more than 350 kilometers through Donetsk, Dnipropetrovsk, Kharkiv and Zaporizhia. Similar to the Surovikin Line, it's made of dispersed camouflage strongpoints, specifically designed to avoid presenting a single target to drone and satellite reconnaissance. Both sides arrived at nearly identical fortification doctrine independently, which means both sides are sitting on belts of trenches, dugouts, and reinforced strongpoints that have to be cleared position by position. Ukraine's broader drone wall, which extends 15 to 25 kilometers back from the front line in places, has made that fight even more lethal for whoever is caught moving in the open. And a thermobaric grenade is uniquely suited to breaking through these defenses on either side precisely because of the physics we started with. Fragmentation can miss the dead space behind a support beam or around a bend in a dugout. A soldier crouched in the wrong corner of a bunker might survive a frag grenade thrown through the door. A thermobaric charge doesn't leave that corner untouched since the pressure wave finds every part of the enclosed volume. That's exactly why a tenfold jump in effective damage volume potentially changes how much of a fortified structure a single munition, delivered by a single drone, can neutralize in one pass. The implication is that Ukrainian units could clear Russian defensive positions while using fewer resources and putting less of its infantry in danger. However, there's a legal and moral dimension here that's worth naming plainly rather than skating past. International law doesn't prohibit the use of thermobaric weapons against legitimate military targets, and every attempt to specifically restrict or ban the category as a class of weapon has failed. What determines legality and what has driven war crimes allegations against Russia's use of the TOS-1A and the ODAB-1500 is the target, not the mechanism. When used against a trench, a bunker, or an armored vehicle, a thermobaric weapon is a legal tool of war like any other, no different in the eyes of the law than a conventional grenade or an anti-tank round. But when used against an apartment building or a residential neighborhood, the same physics that make it devastating in a bunker make it a mass casualty weapon against civilians. The latter point is the core of the allegation of a Russian pattern of urban bombardment in cities from Grozny in 1999 to Aleppo in 2016 to the Ukrainian towns hit by the ODAB-1500 in the 2020s. Ukraine's stated doctrine across the RGT-27, the RGT-45, and the drone-delivered TB series has been consistently narrowed to trenches, buildings occupied by combatants, and vehicles. Whether that doctrine holds perfectly in every engagement, in every unit, across a war grinding into its fifth year, isn't something anyone outside Ukraine's military command can verify with certainty. But the pattern in the open-source record across years of documented strikes is consistent. Russia has scaled thermobaric weapons toward mass effect against areas that include civilians. Ukraine has scaled the same underlying physics down toward precision against a single room, a single vehicle, a single fortified position, and every known engagement fits that intent. The RGT-45 isn't dangerous to Russia because of its size. It's dangerous because it represents not only how differently the entire category of weapon could be used, but also because it underscores just how much collateral damage Russia is willing to inflict on Ukraine to achieve its objectives. It also represents broader failures of Russia's military technology, which never managed to scale down the weapon while also keeping it effective. Now, if this was useful, please like and subscribe as we cover weapons developments and battlefield doctrine from Ukraine, Russia, and NATO every day.